So we are done with the sorting algorithms, right? So now we are going to learn about more sorting algorithms. So we have done the divide and conquer strategies, right? So besides, you can say we can categorize these existing sorting algorithms like they are based on selections, or you can say more sort and quick sort. They are based on the divide and conquer strategy, right? But there are certain other algorithms which are not lying into this category, but they are also used for sorting. So one of the popular sorting algorithm that is based on the tree structures, right? So that is called as heap sort. So this sorting algorithm, basically what do? We represent all the data that we have in the form of an array into a special type of a binary tree. We call it as a heap. So what is a binary tree? What is a binary tree? Soumya, what is binary tree?
Ma'am, it is a non-linear data structure with ma'am two nodes for each root.
So where we see in the trees, when we are saying some non-linear data structure, the representation is in the form of a hierarchy, right? So and this hierarchy is in the way that we have always one root node, right? One root node. And see, when we are saying it is a binary tree, we are saying it has two nodes, right? Two child nodes, one parent node and two child nodes. And when we say it is a complete binary tree, that means it has it is all you can say most of the time we move on to the next level once we have assigned two children to every node. So once we start with the root node, first we will assign both the children to this particular node, and then we will move on to the next level to make it a complete binary tree, right? So only the leaves, we can say, in the complete binary tree is only the leaves. When we reach to the level of the leaves, they may have one children, but otherwise the tree will be complete, right? So when we are saying it is a binary tree, we say it has two children. Now, sorry, in the you can say in this particular sorting algorithm that we call it as a heap sort, there are basically three steps, right? Three steps that we perform. One is heapify, second is we go for the build heap, and then finally we go for the heap sort. Now what is heapify? See, your heap sort algorithm, when we say, it has basically two types. One is called as the max heap and another is called as the min heap. In the maxi, when we, because in the heap sort algorithm we are representing all the data of the array in the form of a tree. So that means in case when we are saying that we are performing the sorting algorithm using the max heap, that means the root or the parent, you can say, the root is the first node, but in between also we have the other nodes. So we rather than using the term root, I will use the term parent. The parent node, the value that is being assigned in the parent node will be greater than its both the children. So like in the see if you can recall it, in the binary search tree, when we were creating the tree, we say all the values on the left hand side of the tree, they are less than the parent node, and all the values on the right hand side of the tree, they are greater than the parent node. But here we are not creating a binary search tree, right? So it is a complete binary tree, it is not a binary tree. So in this case, we say we are going to create a max heap, and this max heap will have you can say in the max heap there is a condition that the parent node will have the maximum value among the three, like the parent and both the children. So there are three there, so the maximum value will be assigned to the parent node. So that means parent node will have the value that is greater than both the children, as compared to the you can say the binary search tree, where the all the children on the left hand side, they have value less than the parent, and all the children which are on the right hand side, they have values greater than the parent. So here we are not creating a binary search tree, we are just creating a binary tree in which the parent will have the value which is greater than both of its children. So we are when we are going to perform the heapify, we are going to maintain this property, and then we are going to make the changes in the tree accordingly. What does the Heapify do? It will pick up the largest child key and compare it with the parent key. Now, if the parent key, see here we are saying picks the largest child key. See, that means we will be basically we will be moving from top to bottom, and then we will see first of all we will see the root node. So the root node and its children we will see. See if the value of the root node is less than any of its children, then a swap will be occurring. Here you can see we are just doing this in this Heapify function. We are doing this particular process only if we are assigning the values of the left and the child right child, and then what we have the value of the root node, and we are just checking this whether the value of the root node is greater than or less than the child nodes that are on the left or the side. If they are the largest, that means we are supposed to swap. If they are smaller than if the values of the children are smaller than the parent node, in that case it will, after passing through all the levels, it will quit because there is no requirement of the swap. So let us see this particular thing in the form of this example. So here you can see we have one example. So in the A, right? So here you can see that we have a tree, and as we move from top to bottom, so we see that 16, that is the parent node, right? It has value greater than its both the children, that is 2 and 3. I'm saying node number 1, 2, 3, right? So among these, node number 1 is the parent, and it has value greater than both the children. So we move on to the next step, the next level. So next level we see the root number 2, the node number 2. In the node number 2 is having a value of 4, which is greater, which is less than its children, right? So if we see the node number 4, which is child of node number 2, its value is greater. So at this point there will be a swapping, and after this swapping we move on to, if we see the B part, this new tree, it becomes a new tree where now the node 2 is having the node 2, which is parent of these 4 and 5, it is having the maximum value. Next we move on to, now see when we are iterating it, you can see it is the value of I. So value of I, the node 4, now the node value of node 4, it is less than the node 9, which is its child. So again the swapping will take place, and after the swapping we get the C, right? The tree becomes, tree will look like that is there in the picture, figure C. So here you can see now this part of the tree is now heapified. It has become a max heap, and now similarly, so it will keep on iterating until all the complete tree becomes the max heap. So here you can say at this particular stage, all the nodes, if you see, they are already in the max heap stage. So the heapify operation performs this particular task. Now, after this particular function, what do we do? See, this was the task of the heapify function, what we do in the heapify. Then we have another function that is called as build heap. We can use this procedure heapify. So you can say for building the heap, you can say in the build heap, what we are doing is we say that if we start from bottom to top, right? If we apply this function from bottom to top, if the children are already in the heap, then there is a least chance that the parent is not in the heap. That means if we start making the heap from bottom to top, then as we move from bottom to top, if the children are already heap, moving towards the root node, the complete tree will be a heap. So there will be a rare chance that if there is any child right in the complete tree, that is not a heap. So in the build heap, we move from top to bottom to top, right? And then we apply the heapify function, and so that we are able to create the complete heap. Now let us see how it is performing when we do the build heap. Within the build heap, we are calling the heapify function. So here you can see this example, we have an array which has 10 numbers. So now see, just putting them in the order. See, we start from the first like when we are given some input array, we just pick up the number one by one and start creating the tree. Like here you can say the node 1 is having number 4, node 2 is 1, node 3 is 3, then node 4, 5, 6, 7, 8. So see here I said it is a complete tree. So we will be completing the tree at every level and then we will be moving down. Right? So at every level we are creating the complete binary tree and then we move down. Now as we see over here, as we reach the value of I is equal to 16. So here we are starting from length of a divided by 2 as we move down, right? So this is I is equal to length is 10 and when we divide by 2 we get 5. So I is equal to 5. We are moving from here. So I5 we see it is 16 and its child node is having the value 7. So it is already in the max heap. Next we move on to the I is equal to 4. So as we move to I is equal to 4, we see that this node is having, this is a parent node which is having a value less than its child node. So the according to that heapify operation, the values will be swapped. Then it moves on to node I is equal to 3. So as I is equal to 3, we we see the value of the parent node is 3, which is less than the values of its child node. Then again the swap operation is performed and then the value of 3 and 10 is swapped. Then we move on to node 2. Again we see the values of the parent node is less than that of its child. So the swap operation, the maximum value is 16. So the swap occurs between the node 2 and the node 5. So the node 2 gets the 16 value, as we can see, from A to B to C to D. And finally, when we reach to node I is equal to 1, that is the root node, that means we have reached to the maximum height of the tree from bottom to top. So here you can see the value of the node I1 is equal to 4, which is less than the parent node. And then here you can see the 16 is swapped with the 14. And finally we are able to get the max heap tree. So from here you can see that the complete tree, if you see, all the parent nodes are having the value which is greater than that of their children. So this is how the build heap function works. So in the last step, now see what is why we are basically studying these heapify and build heap. The main objective of studying this is that we want to apply this heap operation, these representations for sorting the data. So for sorting the data, what we have is the heap sort algorithm. Within the heap sort algorithm, what we are calling here, you can see, we call that build heap function that we have just discussed. So for I is equal to length of A, that is we move from length of A, that will top to bottom, right? So the highest value lies at the bottom and the minimum value lies at the top. So if when we see the length of the tree, right? So what do? We swap and we call that heap size of A is equal to heap size of A minus 1. So what we are doing over here is now, when we are building the heap, after building that, we are going to see this heap sort during this heap sort operation, what we will do, we will be doing the, see earlier we were doing the insertion operations, now we will do the your deletion operations. So we will be removing the root node one by one and placing it in the array that we want to, because our goal was to take the input array, represent it in the form of a heap, then apply the heap sort algorithm. During the heap sort algorithm, what we are going to do is we are going to remove the topmost value, put it in the array at the appropriate position, and then one by one, then we again apply the heapify, make it to retain that property of the max heap. Then we keep on removing and iterating to this process. So here you see this particular example. As we start, see, after applying that heapify operation, we were able to get the figure A from this, right? After applying that figure A, what do? We are removing node I is equal to 1. So we start with the root node. So node I is equal to 1, that is 16. We remove that and we place it in the array A that we see that you can see at the bottom. Now after removing this, we will have to again see, because we have removed this, that the complete tree will be changed. So now the 14 becomes the root node. So all this operation will be done using the build heap and the heapify function. Then See, similarly, after the 16, with the, again we are going to remove the 14 and we are placing them in the appropriate positions. Here you can say we are placing the 16 in the last, the 10th position, then 9, 10, and accordingly we are able to get the complete sorted array from here. So this is how we iterate over this and we apply the build as well as the heapify operations. Is there any noise coming up? Aniket? Aniket, mute yourself. Mute yourself, Aniket. Right? So what we do for I is equal to length of A, do swap A1 to AI, then heap size is reduced to AI to AI minus 1 because earlier it was 10, then it becomes 9, 8, 7, 6 like that. And then what we are passing? Heapify A1, right? So we perform the, from the beginning, what we are doing, we build heap and then finally we keep on heapifying that. Heapify operation, what it will do, it always maintains that max heap property. If the parent node is having a value less than its child, it will swap the values and then make it a heap that is the max heap. So now if we see the time complexity of that particular algorithm, build heap algorithm will run in O(n) time. Then there are n minus 1 calls to heapify, and each call requires O log n time. So the total of time it is taken by the complete heap sort algorithm is the time taken by the build heap as well as the heapify. So its running time becomes an O n log of